Welcome, welcome Vitalik, welcome Andreas, once more Andreas to our space. Thank you for joining us today in this very interesting interview that you will be about to host. We decided somehow to expand the time that we were planned to do this interview. I think it's the most interesting talk of this event. So please be free, yes, to take 40 minutes, 50 minutes in your talk easily. And I want to welcome Vitalik once more to our space. Yes, welcome to the VidConf. We are very highly excited of hosting you here. Yes, for us, it's a very special moment. So thank you, really thank you for joining. Yes.
No, thank you very much. It's good to be here.
And
thank you so much, Rodolfo.
No, please. Thanks to you, Andreas. Please, feel free, welcome, and enjoy. Get fun.
Fantastic. Thank you so much. You know, it seems to me that this was presented a bit as if it's going to be a grand battle between Bitcoin and Ethereum. And so I wanted to just dive right in and ask you directly, Vitalik, are you ready at this moment to denounce the Ethereum 2 scaling program, to recognize that Bitcoin fixes this, and to just stop trying?
I mean, I think absolutely. Like it's we've definitely tried for a really long time, but we have just realized that ultimately just having a plain old proof of work chain with 1 gigabyte blocks is Satoshi's vision, and it is the correct way to make a blockchain. And that's what we're going to be striving toward from now on.
Okay, fantastic. So now that we've cleared the air and we've passed that obstacle, we can talk about some other topics, maybe. So thank you so much for taking the time to talk with me. Most people in this space know you only as the inventor of Ethereum. But I think the first time I met you was in 2013, and you were the co-founder of the Bitcoin magazine. And Ethereum wasn't yet on the radar. And even after Ethereum became obviously your main project, you've maintained a fairly broad set of interests that go well beyond Ethereum. I read your work, I see your blog posts and things like that. You write about Ethereum, obviously, you write about consensus algorithms and blockchains, but you also write about governance. You write about applied mathematics and applied cryptography. You're interested in languages and have mastered several of them, some quite fast. You play chess. You have a very broad range of interests. And in many of these areas, you are a prolific producer of ideas. How the hell do you do it? Because I can't imagine how you fit so much in a day. Is there a plan? Is there a system? Is there discipline? Do you just wing it? What does a day look like?
And I think one of the biggest things is that there's definitely kind of 3 parts exploring to 1 part building at least. And I think that's probably true with kind of most idea people that I know about, right? Like, for every new idea that you can come up with, people have 2 parents, ideas often have like 10 or 20 parents, and you have to kind of come up with, take a bunch of these things from all these different contexts and find different ways to kind of put them together, even find ways to put them together that people have not tried to kind of put them together before. And I think the crypto space is actually an excellent breeding ground for this kind of thinking, right? Because if you look at even just like how interactions between chains and interactions between hard forks and Ethereum Classic, Bitcoin Cash, and now we have BAB and all these different delegated proof of stake and all of these systems, right? And like it basically recreates well, originally we thought we were recreating finance, but it also recreates governance, it recreates politics, like the way that I sometimes kind of twist Peter Thiel's quote about flying cars in 140 characters is that the crypto spaces version is we thought we wanted digital nations, but instead we got digital nationalism. So basically, like, it recreates all of these phenomena, but in a way that's kind of divorced from, a lot of the biases and preconceptions that we, with our attachments to various concepts that have been invented by dead people 300 years before us. And here it's this kind of very new environment, and it's just very open to kind of abstract thinking. And so, like, I spend a lot of my time just reading lots of different things. One of the things I've started doing is, in addition to reading, is also just going on 20-kilometer walks and listening to long-form podcasts. Then for more mathematical things, I've done the ZK Stark and ZK Stark blog posts. In those cases, the best way to learn is actually to just build the thing. Right, like, you don't actually understand an algorithm, I think, until you've kind of coded up an implementation yourself. So, and then, like, and then you do kind of all of these different things, and eventually you just kind of start finding connections. And this applies both to kind of generating ideas in general, and also a lot of these things do end up kind of feeding into things like the Ethereum 2.0 spec, for example.
So you cast a wide net, you listen to a lot of things, and then you see connections between all of these disparate topics that feed into your work. Would you describe yourself as someone who is always busy, or does this just not feel like work at all?
It's a good question. I mean, it depends on the kind of work. It's some of both. Like, it's definitely busy, and it's definitely on the end of active and always doing things aside. I mean, it's definitely not boring. I can say that much.
Right. I think a lot of people misunderstand the role you have in Ethereum. And I'm going to just throw this question out, hopefully not blindside you. But a lot of people see your role in Ethereum as the sage that sits on a podium, and then developers come to you and they ask questions like, what is the answer to life, the universe, and everything? And you say 42, and then they go and build it. Anybody who's actually watched or listened or participated in any of the Ethereum developer calls knows that's not actually how it works. And in fact, not only do you take ideas from other people, and it's a conversation, but often the idea that you pursue ends up being wrong, and somebody else's idea ends up being the one you pursue, which I think we saw very starkly with the two versions of Casper for ETH2, right? That was a very long-running intellectual debate, and it wasn't settled at all, and you didn't just decide. So what are the biggest mistakes you've made, and what have you learned from those by being in that role?
So, and there's, I guess, probably two kinds of mistakes. There's kind of technical mistakes and there's social mistakes. I could talk about both. They're interesting in different ways. So, I mean, technical mistakes, there's definitely a lot of kind of dead ends that you can see in the existing ETH1 spec that we're only cleaning up now. Like, even just things like, for those who understand what this means, the fact that we use a hexarray tree instead of a binary tree, right? Like a tree where kind of every node has 16 children instead of 2. And we had some reasons why we did this at the beginning, but then like only 4 or 5 years later, when other people came along, then we realized, like, oh, it turns out the data structure you use for hashing and the data structure that you use to store on disk don't even have to be the same. And so the reasons I had to be hesitant about binary trees were actually completely wrong. And so now, like, we basically have to do the work of kind of replacing that old tree with a newer structure, right? And so there's a lot of these examples of very suboptimal things that just exist in Ethereum, basically because 5 or 6 years ago we were 5 or 10 people, and we didn't really know better. the 256-bit VM is a constant source of pains and joys. Also RLP. What else? Even some like things around the. Actually, I think the proof of work algorithm, like even though we're switching the proof of stake, I don't think that was a mistake, and I actually think that it was good to have that for at least a couple of years as an alternative mechanism of issuance, just to make sure the coin isn't fully concentrated in the hands of people who bought in the sale. So that was a good decision at the time and a good decision to switch, in my opinion. So, and then there's this big long list of things like that. And then there's even cases where, and as you said, like I had an idea pushing in one direction and then other people went another way. And then even before it got implemented, I realized that the other person was correct. So like I credit Justin for trying really hard to push ETH to use BLS, which was something that I originally resisted. But it ended up being hugely important for us. It ended up being like really good for.
What's BLS again?
Sorry, this is it's an elliptic curve signature scheme. The thing,
yes.
Well, like the thing that matters about BLS, like why people care about it at a high level, is that this concept of aggregation, that you can take a whole bunch of different signatures and just add them. Like, it's just a mathematical operation, take a bunch of these numbers and combine them together into an object that's of the same size, and it represents an arbitrary number of signatures, and so you can have blocks that contain lots of things, and they're still tiny and fairly easy to verify.
Similar motivation to Schnorr signatures, implementing in for signature aggregation in Bitcoin.
Right, exactly. Except with BLS, the really cool thing is that the aggregation is non-interactive. So you can just literally take other people's fully finished signatures and you just combine them together locally and you're done. So that's just on the technical side. On the human and social side, I think, the first big error I made in Ethereum was just the whole, let's invite pretty much everyone who responded within the first week to be a co-founder thing. Like the way that Ethereum worked at the beginning, right? It was like I published this white paper, and then people started replying back saying, "Hey, I want to help." And basically, the first 10 people who did that became kind of co-founders of the project. And there are definitely some people who kind of came out of that process who stuck for the long haul, but there was also a lot that just kind of got into roles that didn't really make sense for them, or people with whom my values were turned out to not be aligned, or it turned out to be much less aligned than I had thought. And in some of those cases, like you don't even know what people's values really are until there's millions of dollars on the line, unfortunately. So there's a lot of kind of painful lessons that I had to learn, and I learned after the fact that out of the VCs who were skeptical of Ethereum at the beginning, the big co-founder team was one of the big things that made them skeptical. So in some ways, they were completely right on that. I guess the thing that they were wrong about is that the project did manage to kind of work its way out of a surprising number of holes at the beginning and prove itself very resilient. So that's one example of just something at the beginning that I think we did do kind of less well than we had hoped, just out of inexperience. Trying to think through some other things. And just like the relationship between the foundation and the community, I think is also just this important thing that we're learning from on a fairly ongoing basis. Like just balancing between, the desire to try to be fair and be neutral versus the desire to like actually support things that need to be supported. And we've definitely had periods where we've kind of erred too much on the cautious side. And so, I think over the last couple of years, the foundation's become much more active, and you can see, the website is much bigger and has a lot more things. There's translations, a big grant program, and all of these things. And behind that too, there's just a lot of people's hard work. And on the administrative side, I am Diego, chair director, and then Ken, Bastian, Sina, Albert, and a big kind of long tail of names. And unfortunately, I have to stop somewhere. So now, one of the also just ongoing learning processes.
Definitely interesting. I like the way you split it into technical and social. I think one of the big challenges in our industry is that people either underestimate the social or overestimate the technical side of this. And it would all be a lot easier if only robots use these blockchains and you didn't have people and interests and motivations and egos and lots of money in the middle of the table for everyone to go for.
Right. And then there's, of course, people on the other side of the extreme who understands the social, but they think that for technical, all you need is Control-C and Control-V. And unfortunately, if you do that, then your socials end up not being very good either.
Absolutely. Great stuff. So I want to switch a tiny bit and talk about our industry and talk about the big questions. Very often I find that people tend to take one small detail that is easy to express, easy to encapsulate, and focus relentlessly on that detail and just obscure the big picture. I'll give you an example. In Bitcoin, almost all of the newbies who come in, they focus on this 51% because it's a number. It's a very specific number. And in there, they see lots of things that aren't actually, consensus is a lot more than just 51%. But that's a good focal point. So everybody gets tunnel vision around that. I think there's a lot of areas in our industry where we get a lot of tunnel vision and focus on the minutia instead of looking at the bigger picture. So what are big questions that you feel we're not giving enough focus and enough discussion that aren't being discussed in the industry?
And I think and the crypto space's kind of relationship with the broader world and just making sure that we're building things that are provide value to just people and kind of humanity in general, and not just a small group. And it sounds a bit cliche because every conference loves to talk about it, but somehow I still feel like that's undervalued to a certain extent. I mean, on the one hand, there are people who keep talking about it, but then on the other hand, there's still kind of a lot of voices that focus fairly exclusively on what gives impressive numbers on DeFiPulse.com or CoinMarketCap or CoinGecko or whatever. And then the other flip side of that question is, can the crypto space proactively do things to kind of minimize the risks of some of the things that it's building? So, just to throw one very simple category, just hacks, theft, scams, and those kinds of things. And there are definitely a lot of things that we have been doing, right? And there's been a lot of hard work on just more user-friendly wallets, for example, right? Just so that people don't end up just randomly losing $200,000 of their money. And that's one of those areas where I think we can have, there need to be kind of a lot more eyes on the problem. And there's technical ways to improve things. There's social ways to, or ways to improve things, but just having more attention on those challenges. So both minimizing risks and on maximizing opportunities, I think something that continues to really be important. So that's probably one big kind of less technical area. Otherwise, there's obviously the items that we keep talking about around privacy and security and scalability and all of those things. And in that, like, I think the broad topics are talked about enough, but there are specific subsets of the issues that don't get talked about enough. Right, so like on the security side, kind of this is going a bit back to the theft section. Just like wallet security is a simple one, right? Like the state of it's still, I think, much easier than it should be to just like lose $200,000 if your wallet breaks. I have a theory that we don't talk about the problem enough because like nobody's willing to admit that they lost $200,000, because if you admit that you lost $200,000, you look like an idiot. And so, no one talks about it. And so people think the problem is small, but actually there's a lot of cases there, everywhere. So like I've been a huge...
It's also, I think, very reassuring and comforting to think that this is something that happens to idiots, and therefore, since I am not an idiot, this can't happen to me. And so when you hear this happening, if you say, oh, it's just an idiot, then that pushes away the fear, right? I think there's a bit of that.
Right, but I think the reality is that like even if you are a super genius and like not just in the usual sense of the word, but you're also like capable of being really careful, like the reality is that a system that requires you to expend less mental effort on just not losing your stuff is still a better system. Right, like we want to be expending mental effort on fun things and on solving the challenging problems of the universe, and not like setting up cold storage setups or whatever. And so basically, I guess I view this kind of big cloud of security, usability, which I don't even view as separate problems. Like I view them as security of or even usability of security. So like that, just trying to kind of come up with better solutions to that big cloud before tens or hundreds of millions more people start getting onboarded into crypto. Because like if the big bubble happens before those problems are solved, then either there's going to be carnage or people are going to gravitate to centralized solutions, and I'm not too happy with either of those outcomes.
And I think we've already got elements of both. There is a fair degree of carnage, and there is strong popularity as a reaction to that with custodial solutions. People don't feel confident to do self-custody. Even though I've given them a handy little slogan, not your keys, not your coins. I've even put it on mugs. People don't want to be their own bank, right? Because that sounds like a terrible burden. And it is with very high risks. All right, so we've talked about some of the good, the bad, and the ugly. For me, one of the things that I find fascinating, which comes as a second order topic here, is identity. At the core, consensus algorithm is a solution to Sybil attacks. In the case of proof of work or proof of stake, these things are to prevent Sybil attacks. Identity is kind of the hidden pillar of everything we do, and the one missing ingredient that if we solve changes everything. Would you agree? Is that something we don't talk about enough, or we talk about it too superficially?
Yeah, and I think that's in terms of like big picture questions. Like there's this entire kind of bubble of identity and also governance, and like identity and governance end up kind of tying together a lot for fairly deep economic reasons that I've written about on my blog, and so like there's this big kind of bubble of those kinds of topics that. We definitely have much less good solutions to than I would like us to have. So I guess like just starting off with identity, it's like people use identity as this kind of big buzzword, but in reality, it kind of combines together a lot of different concepts, and I've always found it better to talk about them separately, right? So the three kind of categories of identity that I talk about, one is just basically persistent kind of self-certified of identifiers, right? So just an identity that you make and you create for yourself, and there is no restriction on how many identities you can have. The only purpose of this is like proving that you who did like action A today is the same person who did like action B last Tuesday, right? And so just like maintaining these persistent identities so you can have persistent reputations. And we have public key cryptography, but also, we want to have like something more human readable than addresses. And so that's why we have ENS. And then we want better key management. But if we want for that, like it's basically the exact same solutions as for everything else in wallet security. So that's in some ways one of the easier problems. And then the second problem, or the second kind of thing in this bundle of identity that I'm unbundling is what I call the unique human problem. So this is basically proving that some account corresponds to a person in such a way that one person either can't, or it's very difficult to create many different identities that one person all controls. And this is useful for, governance is definitely one, right? If you want to have a governance mechanism that is not a plutocracy, you need to have some, and it's formalized, you need to have some identity model. Another one is if you want like anything, UBI-like or per person airdrops, needs some identity model. And like one example of this, right, is if you think about the Uniswap airdrop, right, it's like, people in general love the Uniswap airdrop, I think. And I saw there was even a thread on Twitter where some either Bitcoin person or just general crypto skeptic said something like, since when has any airdrop led to anything good happening, basically? And there were like 5 replies that were all saying, hey, don't you remember Uni, right? And the thing that was fascinating about Uni was, I think, just the sheer size of it, right? Well, and also just how well targeted it was, right? So basically with Uniswap, what happened is that there was this airdrop of the Uni token that they announced, and it was this retroactive, like basically like stimulus check, like literally it was something like $1,400 going to pretty much everyone who's ever historically used Uniswap, right? And so, and like and there was a share it's going to liquidity providers that was kind of proportional to how much liquidity you provide, but the great bulk of it, like something like 2/3, it was basically on a per address basis, right? If your address ever used Uniswap, like ever traded, then ding, you get 400 Uni, and there's your stimulus check from Lord Hayden Adams. Well, I guess he's not really in control of the thing, but you know what I mean. And so, and like that made a lot of people really happy, right? It created these great community dynamics, and especially in kind of a lot of poorer countries, it just ended up randomly just making a huge difference to the lives of crypto enthusiasts for whom $1,400 is a really huge amount of money. But of course, the big kind of elephant in the room is that this was per address, right? And
right.
If it becomes a pattern to do it per address, like the only reason it was secure is that it was done once. If it becomes a pattern to do it more than once, then eventually people are going to start farming addresses and just like interact with every application, like from like 1,000 different addresses, and so the whole thing will break. And so if you have...
And not only will it break, it's a denial of service attack on the infrastructure, because all of these things, if they can be gamed, they effectively become denial of service.
Right. So if you have a unique human solution of some kinds, then like theoretically these kinds of things become more sustainable, right? And so, we actually can try to have more airdrops where it doesn't just go to the whales, basically. So that's part 2, and I know the kind of the unique human thing is controversial in the crypto community because like there is this desire to be anonymous and try to get away from IDs. And my response to this is that, well, you can combine this with zero knowledge proofs, and you can do really fancy things like prove that you are a unique human without releasing any information about which unique human you are, because we know ZK Starks what you do, awesome things like that. Some people are convinced by this, some people are not. But at the end of the day, crypto is a free ecosystem, and we have lots of experiments. So we'll see how this goes. So that's part 2. And then part 3 of identity is just attestations, right? It's like, I say that that I believe you are trustworthy, or this, a certification agency says that this person is a certified Bitcoin professional, or
a certified Ethereum professional.
Yes.
As our new certification we're launching, which I'm going to plug shamelessly right now. Thank you.
Excellent. Yeah, so those kinds of things are also part of the identity problem. You can prove citizenship potentially. You can prove reputation. You can prove competence. You can prove a lot of different things, right? And so, applications that have to do with that are also part of identity. But you can also see how it's kind of different from both the unique human problem and from the problem of just being able to maintain any kind of persistent account. So that's how I see kind of the identity landscape actually being this kind of jumble of a collection of different landscapes. And we're seeing kind of solutions slowly creep forward in all of those categories. I think the successful solutions are not going to be the ones that come from people who say, we want to solve identity. They're going to come from they're going to be demands driven, right? They're going to be solutions to that appear because people have a need for them. One example of this, I think, already happening is that the unique human thing was just completely theoretical, basically up until Gitcoin grants quadratic funding started to have a need for it, and then suddenly people were interested. Right. And I think for credentials, there's we're going to see something similar. There's going to be a killer app at some point. Maybe one of these, decentralized payment for task things are going to only accept submissions from people who have some credential. I don't know what it'll be, but just look for that first kind of, well, not really a killer app, but at least some app that's big enough to bootstrap the thing, and yeah.
And a universal basic income faucet that requires Sybil resistance is one that I'm also seeing as relating very closely to solving specific identity problems and driving demand, which then goes back to the previous conversation we were having about the motivation around helping humanity and not doing it for the cap table of the investment class, but looking at people for whom even a small amount is life-changing, like you described. All right, so I want to pivot a bit to some more technical topics. You've mentioned ZK Starks 4 or 5 times already in this conversation when we weren't talking about ZK Starks. Roll-ups and zero-knowledge proof have been a game changer. And specifically, they've changed the way the ETH2 roadmap has rolled out. And I think rescheduled some things, pushed some things out, made some things less necessary. So what's your general perception of how big this zero-knowledge space, roll-ups, optimistic roll-ups, and all of these other technologies that have just emerged really in practical applications, how do they change the roadmap going forward?
And I think they're definitely big. And one of the comments I made a couple of months ago, right, is that there's this debate about, do we call it the crypto space or do we call it the blockchain space or the cybercoin space or whatever else? And I'm as much as it's kind of calling it the crypto space does kind of collide with traditional cryptography, I just find myself forced to admit that calling it the crypto space is the least bad of at least those 3 options, unless you can come up with some number 4. And the reason for that is pretty clear, right? It's not the cybercoin space because blockchains are not just about cybercoins, and it's not just the blockchain space because blockchains are not the technology is not the movement, right? And and I think zero knowledge proofs are actually the second big category of technology, like in my opinion, like equal in importance to blockchains, that the movement is latching onto, right? So basic, and I think blockchains and ZK snarks are really nicely complementary in an amazing way, because blockchains give you guarantees about kind of execution and censorship resistance at the cost of scalability and privacy. But ZK snarks, what do? Well, they give you back the scalability and privacy, right? So like the two technologies just fit together, just so perfectly. And I think that this is a big part of the reason why there's just so much excitement around them. And another thing is that zero knowledge proofs have just jumped forward amazingly quickly in the past year, right? Like one of the kind of quiet things that has happened, I think maybe about 15 months ago. This was when we were in Tel Aviv in September, and it all just happened within the space of a few weeks, was this what I call kind of the polynomial commitment revolution. Like, and the idea basically here is that like we created this new this not new mathematical object. We created this this new realization about the importance of this mathematical object called a polynomial commitment, which is basically, so a polynomial, it's this mathematical equation, y equals something times x to the power of this plus something else times x to the power of that. And you can have like a lot of different kind of terms in a polynomial. And polynomials are really important objects because they can represent a huge amounts of information. And polynomial commitments kind of points to that huge amount of information in a very small thing, right? And they also allow you to make claims about basically equations about polynomials, which actually are because they're equations about very big things, they actually hide like a really huge number of statements, right? So if I say this polynomial times this polynomial equals this polynomial, that's actually hiding kind of millions of math equations in between, and we're basically just checking millions of math equations all at once by actually checking one equation, right? That's like one, I think, good high-level intuition for understanding them. And basically what this polynomial commitment revolution is that we've discovered that there's basically ways, if we use polynomial commitments as this ingredient, we can just make incredibly powerful zero knowledge proof protocols, much stronger properties. You can make the trusted setups work much better, or you can get rid of the trusted setups, or you can create a protocol that starts with one scheme and then you just seamlessly move it over to another scheme, and then you can start with a trusted setup and then eventually get rid of the trusted setup. So it just unlocks a huge number of these possibilities, right? The protocols get simpler and more efficient and more modular, and faster innovation, just all at the same time. And as a result of this, I think we've seen Plonk, we've seen Plookup, we've seen just a lot of this protocols start moving forward really quickly. And of course, at the same time, I know the production side has been moving quickly, right? So like we've been seeing like these ZK rollups start hitting mainnet. So that's, there are now live layer 2 scalability solutions on Ethereum, which is, theoretically capable of more than 3,000 transactions per second. You just need people to use them, and people are starting to use them. And then Tornado Cash, I think also ZK snarks for privacy. That's also something that, now exists, and you can go use it. So I guess, there's been a huge amount of progress there, and it's hugely relevant to privacy and scalability on layer 2. And it's also relevant to layer 1 because, well, first of all, we can design the layer 1 around knowing that these powerful layer 2s exist, right? That was the whole rollup-centric roadmap thing. But also, we can potentially incorporate these technologies at layer 1 as well, right? And so, we can replace fraud proofs with ZK snarks. You can make protocols safer that way in a lot of cases. So a lot of possibilities there. And then rollups themselves, I think, are definitely worth mentioning. And rollups are powerful just because I think rollups are the first layer 2 scaling technology that's that the Ethereum kind of space as a whole has kind of managed to really find compelling. And there's very subtle reasons for this, right? And I think one of the reasons is that the Ethereum community is not just trying to do payments, right? Because if you're just trying to do payments, the Lightning Network works great, and Plasma works great. You have more solutions, but the Ethereum community has been trying to do these things with smart contracts, and you have DeFi, and there's these projects like Synthetics, there's projects like prediction markets, automated market makers, all of these things. And these are Ethereum applications, and they're written in Ethereum code. And rollups are the first scaling solution that actually managed to kind of replicate a full EVM on layer 2 trustlessly, right? And like that's challenging. That's it's challenged. Like there's these deep technical reasons, right? Why like things like Lightning and Plasma have a hard time doing it. And like, to be clear, like this isn't like this is not coming from a place of like me wanting to dunk Lightning. Like this is coming from a place of like I've spent years trying to make Plasma work with this, and even in the case of Plasma, we've had these problems, right? Like basically, the reason why those protocols get their efficiencies is because they rely on these assumptions that basically say we're going to devolve responsibility for managing data to the individual user. And that's a great model for scaling, but it doesn't work for applications where there exist like parts of the application that have no owner, right? Like
I think this is a great point to kind of wrap things up, because we're ending on a very optimistic note. The ZK space has exploded in innovation. A lot of this stuff is moving into production much faster than research stuff has moved into applied production before, because we have these new platforms. And would you say just yes, no? Are you very optimistic about the future?
I am, yeah, and I think I'm more optimistic about the future of crypto than I ever was before.
That's fantastic. Vitalik, thank you so much for spending the time with us today. It's been a real pleasure chatting with you again. Rodolfo, back to you.
Back on stage, yes. Thank you. Several of the topics you've been talking today, Zcash, seed snarks and privacy, they were discussed the first day of the conference, so I invite everyone to check also past talks of LabitConf of this year. Thank you, Vitalik, for joining us. Thank you, Andreas, for driving this. I asked you to do it more into the human side also, and it was really superb the way this interview worked out. I'm really thank you both, yes, to taking this invite of do this very special talk that people is saying it's like the best interview of the year. So thank you really for your effort and for joining us.